Hello, hello. Okay, so I was definitely all the stream. I have no idea. ठीक है. Hello. Yeah, I'm audible. Okay, okay. So I was definitely on all the stream. Now I'm audible. I don't know why I do these type of mistakes today. Really, I don't know why today they was like very very bad for me. I'm keep getting this a bad day. I would say this. Okay, let's just keep going. Okay, let's not waste any more time. I already have wasted too much of time. Okay, so yeah, I just wanted to say, yeah, I was saying something. I was saying about. Let me just. Okay, I'm audible. Okay. So I was just saying, today's stream will not be something special. So today we will be learning about. We will not be learning about any particular thing. We will be just revising all the topics that we have learned till now, and I will highly suggest you guys also, if you are someone who is learning something, I will suggest revision is very important part of learning. Even though you completed a video on in one day, even if the video is of 10 hour or 1 hour, it does not matter. You should revise it at least a week. Okay, so that like these concept will be embraced on your memory, and it will not fade faster, because the faster you learn, the faster you forgot if you don't revise. Okay, so today's stream will be around these things. We will be revising or these topics, and yeah, and we will might also be exploring some other topics like Java. Okay. Let's see what will we do in the rest of the stream. But one advice that I will give you to how you can revise a particular topic is to just read all these notes that you have made, if that's the case for you. If that is not the case, you can do one thing also. You can just uh, take all these topics and ask the ChatGPT to uh, ask something related to these topics. And if you have notes, you can feed all the notes and ask ChatGPT to ask something around these notes. Okay, so yeah, that is how you can revise. I will be revising in a similar manner, firstly I will be revising line by line by my notes, okay, and then we'll be revising it by ChatGPT. ChatGPT will ask some of the questions and I will be answering them, or I will be trying to answer them. Okay, let's start from the very start. So we were we were to we were to start from the basic terminology. We were firstly we have learned about how does the internet work. So let's start from there. So these are the basic terminologies that we learned at the very start, which were packets, router, IP address, domain name, DNS, HTTP, HTTPS, SSL. Okay. So packets are nothing. Packets are a small unit of data that transmitted over the internet. So these are all. This is the definition. It is not something which is very hard. Okay. It is as the definition suggests, data which gets transmitted over the internet. And what router is? Direct. It is a device that directly transfer those packets or the packets of data. Okay. Over different networks. Okay. So those are nothing that are routers. Okay. What are IP address? So IP address you can say it as like a coordinate, okay, over the vector space, or over, let's say these are the coordinate of uh, your home, maybe, or your home over the map. It could be an Indian map, it could be a global map, okay. So if we go to the those longitude and latitude, okay, it will be pointing to your home, or maybe some other thing you could take example of. Okay, so those are something called IP address. It is a unique identifier assigned to each devices, so that they over the internet we can identify a particular device. Okay, so this is something we should know now. And there is something which is a domain name. So these are not something which is which this is a topic which is needed for especially for a user. Okay, this is not a topic which is required as technically as it as the other as others. Okay, so domain names are for easier for the user conventionality. Okay, so that like user feel it यूजर फ्रेंडली. ठीक है, तो यूजर की कन्वीनियंस के हिसाब से जो चीज़ें रहती हैं वही उसके लिए ये चीज़ बनी हुई है. ठीक है, डोमेन नेम. So like let's suppose for a normal user or for anyone, okay, it is not yeah, so it is not easier for them to learn or to remember IP address. So let's suppose if a person they wants to visit Amazon, so he really want to, or does he really have to remember the IP address of Amazon? No, right? So how can he be able to easily access those Amazon? Okay, so that is where domain name comes in. So this is a, but you could say, particular human name that is to used to identify those websites or the IP address. So how does these both those are both connect? Okay, how does we connect from IP address to domain name? So that is where the DNS comes in. Okay, the DNS is nothing which is responsible for translating the domain name into the IP address. Okay, and so yeah, that is all. And there are some protocols. Protocols are nothing. Protocols are set of instructions that is being followed to transferring those data. Okay, so there is one protocol which is like HTTP, the hypertext transfer protocol, which is used to transfer data between client and the server. It could be either way, client to server, server to client. Okay, the but the data that we transfer in HTTP is not secure. People might can access it. Okay, but that is not the case in HTTPS. the data is being encrypted, and encrypted version of HTTP is used to provide this secure conversation between client and server. So yeah, it is, as the name suggests, it is used to encrypt the version of, it is an encrypted version of HTTP. You could say that in simple language. Okay. And there is other concept which is SSL, which is nothing, which is secure socket layer. Okay. So this is a security protocol which are used to like provide a secure conversation over the internet. So these are the peoples, like, or you could say these are the uh, this is the layer which provide the securityness, okay, which provide the HTTPS wala thing, okay. So with SSL certificate, you can make your HTTP website to HTTPS, okay. So some of the website name, some of the free website name I also like told you, which was Certbot, okay, which I have also used in my projects, okay. My pro or you could also say my intern, okay. Yeah, these are all the basic concepts and terminologies that we discussed in internet. And we also discussed how when building application on TCP, there are a few key concepts that we needed to understand or we needed to aware of. Those are ports, sockets, connections, and data transfer. Okay, the ports are nothing. Let's suppose even if in a particular IP address, or you could say even in a particular, let's say if you are coordinating or you have the coordinate of your house, so which is your room, okay, where in which door I have to knock to, so that like you open the door, okay. So how does that this being decided, okay. So this is where the ports comes in, okay. So these ports are used to identify an application or a server running on the device. So they even in a single IP there are multiple services that are being running, okay. So how can we decide that in which door, you could say in simple terminologies, okay, is the back end is running or is the front end is running, okay. So these are something that are first needed, okay. And sockets. So sockets are nothing, which is a combination of IP and port. Okay, so that is what the combination of IP and port are represented as socket. Okay, so socket. So the definition is also like this, representing a specific endpoint for communication. Socket is a combination of IP address and port number. Okay. So sockets are used to establish the connection between devices and transferring data between applications. Okay, and there are connections. Okay, the connections has to establish uh, to like begin to begin the process or to have to like transfer the data to know that this is the person there that like the let's suppose for the user case, okay. So user have to know that the server is present there, okay. So for that the connection has to establish, and even for a server it has to know that the client is present there. So there is a mutual connection, or you could say, okay, to have to present, and they needed to come to an agreement that these are all the various parameters that we can agree upon to have to transfer the data. Let's suppose if you are in a laptop, okay. So you need to resize your window, or you could say uh, responsiveness of the website is being decided on the basis of connection, okay. So in, let's suppose I have also given you the example, you have seen your the same website in phone or in laptop differently, because there through this connection they decided into how the what is the window size, what is the segment size. So these are all the things that have already been programmed by the programmer, and they has been deployed by deployed in the server. But they have, through these connections they have decided that like this is my configurations that I be requiring. Let's suppose for the phone, this is the window size for my phone. You needed to transfer in these format. Okay, so yeah, that is one good thing. And then the data transfer happens. So yeah, this is all the terminologies. SSL, you also needed to ensure that you have obtained and maintained valid SSL for your services, and that you follow the best practice for configuration and securing your SSL. So yeah, this I have already told you. So yeah, just skip it. Okay. Uh, then we study about what is a HTTP. So in HTTP, let's see. When using HTTP, you are really using several protocol beside HTTP at the same time. Each of these protocol are stacked, has its own features and responsibility. So yeah, that is true. We have already discussed. Okay, so in HTTP there are different protocols. So there was this TLS, then there was this which help us to encrypt the data. Then there is TCP, which help us to transmit the data. And yeah, and for the HTTP3 there is QIC, and there is, which was built on top of UDP, and then it is mandatoring the TLS, which is not required, or the mandatory which is not like a must need for, or you could say which is a not mandatory in TCP. You can attach TLS layer in top of TCP, but it is not like they have this uh, configuration that you needed to apply the TLS on top of TCP, which is the case in QIC. Okay, so yeah, that is what we have discussed. For example, while HTTP deals with URL and data interface, and TLS ensures security by encrypting. Yeah, that is how I told you. TLS is to encrypt the data, and TCP enables reliability data transfer by transmitting lost packets. So yeah, TCP is to TCP TCP's job is to ensuring that the if the data has been lost in between, it needed to retransmit the lost packet. Okay, so how they do this? Okay, so uh, this is tracked bit packet by packet through the connection that the data has been transferred, and there is a handshake thing. Because there is a TLS sorry, TCP handshake, where it like confirm that the packet or the segment or the stream is being transferred to the client to the client side. Okay, so that is how they ensure with the help of TCP. So let me draw a simple drawing so that you can better visualize it. Okay. So let's say this is server, and let's say this is the client. Uh, so the client sent a request to the server, and then the server responds to client. Okay. Is it, ah. So when the client requests something from the server, and the server responds it with the data, okay, which client has requested. So then after then there is a handshake, which this handshake ensures that the data is successfully transferred to the client. Okay, if if this handshake does not happen, okay, and so that means that data is not being transmitted. So the server just retransferred the whole data, and in TCP, all the files, all the data, just transfer in one go. Okay, okay. So let's suppose if a client asks for something, it just transferred all the content in one packet. Okay, so if this packet gets lost, all the data gets lost. We have no way of recovering anything. So there was this problem of whole of which was what, I forgot the particular name. It was something around, was something like whole of which It is something. Okay, it should be here, right? I have noted it down, but I just forgot where was it. TCP, UDP, lost data boss. Okay, where was it? Okay, we will be reading it. Okay, so there was. Let's not go to the particular word and understand the concept. Okay, so in this case, what happens is, let's suppose if you are transmitting the data in one particular packet. Okay, so if let's suppose you are downloading 100 GB data. Okay, so if the in TCP, if the packets get lost, okay, in between, so it has to retransmit that whole data from zero. Okay, so in case of, let's suppose if you are downloading something which is a very large file, which is, let's suppose of 100 GB, and if the gate in 99% the data gets lost. Okay, so you needed to start it from 10, which is not the case with this QIC, which is beneficial. We will be studying about it, how is it happening. Okay, and what is it, how is it benefiting us. Okay, so let's uh, know, let me tell you the problem that is happening. Okay, and how is it happening. So this is what structure of HTTP2 and HTTP3 looks like. There is a layer of TLS, okay, on top of TCP, which is not the case for HTTP3, where the QIC layer is being made on top of UDP with the fewer powerful popular feature of TCP, okay, included, and there is a must or mandatory TLS in it. Okay, so you needed to implement TLS on in QIC, and how is it implemented? We will be seeing it in the below diagram, but let's read this first. Okay, TCP require a handshake to set up a new connection. I already told you. So there was this problem also. Okay, so TCP needed to form a new connection every time this client want to ask something. Okay, so it needed to form this every new connection, which is like, let's say, for few requests, not making much problem, but for the large number of requests by the client, it is like been getting so much problem. And let's suppose if if the client is far from the server, let's suppose the client is far from the server. Let's suppose you are a client or you are a user from India, and the server was on US. Okay, so it will take quite much of time. That is that the time is also called round trip time. Okay, RTT. Okay, we will be discussing some other concepts also with like 0 RTT, 1 RTT, but let me know you that the time is called round trip time. Okay, so it will be the how much time. uh, RTT is nothing. RTT is like how much time it is take to, how much time is been taken to uh, when a client asks for something and it goes to server, and the data comes back to the client. Okay, so the whole time is been called round trip time. Okay, so if the server is far from the client, okay, so it will take too much time. Okay, for one request it is still okay, but if there are multiple requests, so it will form a new connection that require much more RTT. Okay, so it is noticeably like 100 millisecond, which is not the case with QIC. Okay, we will be discussing that also in for going forward. And let us discuss how does UDP work, or what is UDP. Okay, because we need to be aware of this protocol also for us to understand what how does QIC works. Okay, so UDP is most barebone transport protocol possible. It really does not provide any feature besides so-called port number. Okay, so UDP provides us these like port number of like the client and the server, and it just directly transfer the data. Let's suppose client is asking for something. It does not care even if the data has been transmitted or not. It just transfer the data. Okay, even if the client does not get the data, it is not his concern, you could say. Okay, so yeah, that is what it in here. It does not set up a connection with the handshake. Okay, so no, nor it is reliable. Okay, so how does it help? We will be building QIC on top of UDP. So yeah, that is what we can take reference of by while building QIC. Okay, so using TCP, we have a reliable connection with the handshake. Okay, if the data gets lost, it pauses everything until it retransmitted the data. That is making a buffer time. So let's suppose if the data has been transferred and in between there is one package or particle or something get lost, okay, or some data gets lost, so it pauses all the process and retransfer the data from there onward. Okay, so that is something which is taking one RTT extra for each time the data gets lost. Okay, so yeah, that is what happening in TCP. And in UDP there is no no handshake, so send fast without checking. Lost data is simply ignored. If even if the data gets lost, it does not care. Okay, and let's discuss how QIC works. Okay, QIC uses UDP with a fast handshake. So there was a cryptographic graphic handshake that happens in QIC and which add reliability with retransmission. Okay, so if there is a quicker handshake, it just uh, having reliable uh, because the RTT is somewhat uh, happening in parallel, you could say. Okay, so how is it happening? Let me tell you. Okay, and the sender data is independent stream, so only the lost parts are resended without blocking. So in case of TCP, if the data gets lost, the whole data from the start needed to transfer because it is something which is like transmitting data whole in single file, okay, or in single packet, which is not the case with QIC. And how is it doing it? We will discussing it below. Okay, let's discuss about what is the difference between 0 RTT and 1 RTT. Okay, this is a good concept to know because we will be this we I have two three doubts how is things happening. So yeah, I get clear to the I got clear of those doubts with the help of 0 RTT and 1 RTT. Okay, uh, which which is this is the doubt I have. I will be discussing about it. Let me just finish this thing first. So 0 RTT is something which is client can send the data immediately using previous keys. Okay, so these are the data, okay, which is being transferred by verifying with the previous key that already, like let's suppose there is a connection has been formed in the first when the first data gets transmitted. So there was a client and server key. Okay, sorry, private and public key in cryptography. Okay, so this is the concept. So let's suppose let me draw it to make you understand better. Let's suppose this is the thing. Let me explain you. Okay, so let's suppose this is the user and okay, so let's suppose this is a server. Okay, and let's just say okay, so in QRC the data transmitted bit by bit every bit by bit. I was wrong. So the data was transmitted in segments. So let's suppose uh, data is something like this that needed to transfer. So it just cut down into segments. ठीक है. तो in first time this much data is being transferred, ठीक है. In second time this much, uh, in third time this much, fourth time, no, wait, fourth time this much, and fifth time this much, and sixth time this, ठीक है. तो and each of these data is of 1400 byte, ठीक है, according to the article that we have read, ठीक है. So yeah, that is how the data gets transferred in QIC. And let's suppose what we were discussing. Okay, so in the very first handshake, there was this key, ठीक है. There was this public and private key. So let's say if a request is being transferred uh, through client to the server, so they has this public and private key that only they have known of, ठीक है. तो only the user can access the data, ठीक है. So that is how the cryptographic uh, handshake happens, ठीक है. So they have this key in the first connection, ठीक है. So with the help of the previous key, the zero RTT are those type of data in the next segment that can be transferred easily with the help of the previous, ठीक है. तो in the previous round, ठीक है. तो let me explain it in Hindi तो so that I can explain you it better, ठीक है. तो let's suppose कि पहले बार डेटा ट्रांसफर हो, ठीक है. तो पहली बार डेटा ट्रांसफर हो तो कि दोनों के पास प्राइवेट की और पब्लिक की आ गई, ठीक है, उस मैसेज की उस सेगमेंट, ठीक है. तो अब जब नेक्स्ट बार जब डेटा ट्रांसफर होगा, जो भी डेटा उस प्रीवियस वाली की से खुल जा रहा है, ठीक है. तो दैट इज अ डेटा of zero RTT, ठीक है. तो these are data which is not sensitive or confidential, ठीक है, to the client or to the server. And what RTT are those data which can't be transmitted or fully accessed by the client or the server, ठीक है. तो until unless the full handshake happens, ठीक है. So I have this doubt. Let's suppose in QRC the handshake and the data is being transferred in, you could say, in an envelope, okay. So these both things happen simultaneously. So I have this doubt. Let's suppose if I transfer the data to the client and the key that does not matches, okay. So how isn't my data been already lost, okay. So isn't the client is going to access the data, okay, if I am giving it in an envelope. So data transferred is categorized into these two categories. So only the data that is not confidential or sensitive is being transferred in zero RTT. So that can only be accessed by this cryptographic way, okay, the secret key. But for the data that are sensitive, let's suppose the user login, okay, credentials. So these are data is categorized as one RTT, which needed to have a full handshake, okay. So to have this to know that server that this guy has the private key. So yeah, that is how things work in QIC. So that is why it is more reliable because it is doing it. TLS, as I already told you, is a encrypting thing, okay. So which is encrypting the data, but it is an algorithm which requires at least 2 round time, okay, 2 RTT from client to server, okay. But later on, this just optimize this TLS, which minimizes 1 RTT from the client to server, okay. So they just improve the mathematical algorithm. And if you want to know what is it, you can read it from here. I will be scrolling it down. I think it was something like this. Yeah, you can search it in the internet, okay. What is this, how is it working better, okay. I am not wanted to dive into it anymore, okay. So that is why I'm just stopping it here, okay. But you can read it on your own, how is it better than TLS 1.2, okay. And then there is this concept of QIC, which is replaced by TCP, which we are using instead of TCP, okay? Which is also reducing one RTT by doing as you can see, QIC is happening at the same time as the as TLS. Okay, so one round time is uh, again reducing, so that is a good thing. Okay, and this is a diagram which is showing how TCP and TLS is working simultaneously in HTTP2, and this is how uh, the QIC is mandating the TLS or layer inside it. Okay, so it is encrypting the data. So there is two encrypting, with one of which is done by QIC, and then another one of is done by TCP. Okay. Okay. So the big changes that happens in QIC. Let's deep into it. Okay. Then there is a little left. So the first key difference in QIC, okay, was it is deeply encrypted by default. So it, yeah, I am not getting the right word. Okay, so it was by default. Okay, so in QIC, it is using TLS by default, which was not the case with TCP. Okay, yeah, that is what you could say. This is not only improving its security, privacy, and characterization, but also helping it deploy and evolvability, it making the protocol a bit heavier to run, but in return allowing other optimizations such as faster conversion and establishment. Okay, so it is making it a little slower because to encrypt the data, even if the mathematical algorithm gets there, to to use TLS or not, because it is taking the same time to get one RTT. So yeah, that is why uh, this is the big change that happened in QIC and QUIC. Sorry. Uh, the key takeaway here is TCP was never designed to transfer multiple and independent over the single connection. Okay, so yeah, that is yeah, that is so true, because when TCP was initially built, it was not meant to transfer multiple or independent file over a single connection, because every time they wanted to form a new connection, it is doing another handshake or just transferring all the data in a single fragment or in a single segment. Okay, uh, that is a drawback, that has its own drawback, but in that era there was no such thing as all these things. So yeah, that is a good start, you could say. Okay, then you improvise, and that is how things work. Okay, because that is exactly what web browser require. This has led to many inefficiency over the year, because there was some inefficiencies, so that is why we require QIC. Okay, QIC solves this by making multiple bit stream. Yeah, I already told you somewhere here. Yeah, so it divided the whole thing into byte streams, so each of the byte is of 1400 byte. Okay, so that is how the data gets transferred. And even if, let's suppose, in between, let's suppose this byte get lost. Okay, so uh, the server just needed to send this specific byte. They don't needed to send the whole data, because it is divided into bytes, obviously. So yeah, that is how the things works. Okay, QIC solves this by making the multiple bytes a core concept at the transport layer and handling the packet loss on the per stream basis. Okay, so yeah, that is how things are working. And the third big change that happens, the key takeaway here is to in TCP, connections are defined by four parameters, so that can be changes when endpoint change networks. As such, these connections sometimes needed to restart, lead to some downtime. QIC added another parameter to mix, called the connection ID. Both of QIC client and server knows which connection ID map it to which connections, and thus did I attach the diagram of it? I don't think so, right? Yeah, I should have. included the diagram. Let me do one thing. I just wanted to include the diagram of it, okay, so that I can even reference it by later if I forgot about the concept itself. But by seeing the diagram, you can understand it easily. I just wanted to uh, using it here. This diagram is also useful, but I just wanted to. I can do one thing. Yeah, I can just do one thing. I can just copy this diagram also. So this is also a good diagram. Good thing I just revise it. Otherwise, I have not attached the diagram. Okay, it's looked good. And there is one other diagram which I initially thought, yeah, which was this one. Copy image. Okay. Okay. So these are two diagrams that I wanted to do. Should I attach it? Should I attach it somewhere here? Okay. Let's just do one thing. Let's do a little downward. Okay. 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 So good. Yeah. So where were we? Yeah, we were discussing about this thing. Let's suppose if they this is the same concept that we discussed. Okay, so let's suppose if you are using a Wi-Fi, okay, so how when you connect to a different Wi-Fi, or you connect to your mobile hotspot or mobile network, okay, so these four there was this thing that is how that is how the TCP is recognizing that this is the same connection that we have, okay. So there was this four tuples that is included of your IP port, client server's ID, IP address, server's port. Okay, so these four tuples include this four tuple that is being used to recognize that this is the same connection. So let's suppose if you changes your Wi-Fi, the IP address of the client gets changed, and TCP is not going to recognize that this is the same connection. It is trying to establish a new connection. Okay, so which is not good because it is like sending data in one particular packet, and if it needed to form a new connection, okay, so it needed to start from the very start, which is zero. And as I already had given you example, let's suppose you are downloading a 100 GB game, and if you needed to re-establish the connection, you needed to start it from zero, which is not a good thing. Okay, so this is not the case with QIC because they introduces this concept which is connection ID. So they are mapping. Let's suppose even if you are using the like if you are using a different Wi-Fi, they are recognizing that this is the same connection with this connection ID. So this connection ID is nothing. This is a something that is being decided by the user and the client. Okay, there is a mutual understanding or mutual the code word you could say. Okay, so let's suppose even if let's suppose you you have this thought in your mind that let's suppose if I forgot about something, or maybe I just change my appearance, how is some other one is going to recognize me? Or let's suppose you have a duplicate, then how is your friend is going to recognize you that this is real you? So you have thought of why not we have a secret code word that only the them has known about, or a secret code name that only the two of both of them has known about. So that could be, let's suppose, masked man. Okay, so if I say masked man, then the other party is going to recognize that yeah, this is the real me. So that is something which is, that is the same concept is connection ID. Initially when the first connection gets formed, they agree on this connection ID, that let's suppose the initial connection ID is K, and let's suppose the IP gets changed. So they have come up with this list of connection ID, and if the IP gets changed, they come with some other connection ID, and in the first connection itself, they both have agree upon this connection ID. So they are going to recognize, yeah, this is the same person, and that is how they are resuming from where they left. Okay, and they don't need it to form the new connection. So yeah, that is how they like uh, solve this problem. So yeah, this is how it is looks, that is this is how it looks like. Okay, so this is the client and this is the server. If even if the if the client IP gets changed, through this connection ID they are going to recognize, yeah, this is the same person. The network is different but the connection ID is the same. So yeah, it is the same connection. That is how it is recognizing it. So this is the big change that happens in QIC, which is not there in TCP. Okay, so the last change that happens, which was not there in TCP, is this. Let's read it. While QIC has now been standardized, it should really be regarded as QIC version 1. Okay, so yeah, I will just going to say something. Okay, there's this person that has written this article. It is this person is a great person. Okay, I'm not belittling it, but he is just obsessed with not recognizing that we really needed HTTP3. Instead, he is suggesting that we only needed something like TCP2. Okay, so that is true to some extent, but yeah, he just included every time whenever he get the chance to say this thing that we really not required uh, HTTP3. Instead, we have required TCP TCP2. Let's just ignore that part. Okay, let's continue. While QIC has now standardized, it should really be regarded as QIC version 1. Okay, is also clearly states in the this thing. Okay, and there is clear intent to create version 2 and more fairly quickly. On top of that, QIC allow for easy definition of extension, so even more use case can be okay. This is not something which is any helpful. I don't know why I just needed to improvise it, what was in the third part. QIC is designed to ease the evaluation, mainly because it is largely encrypted, allowing update to happen and at end without needing changes across the entire. Okay, yeah, so this is something which has been helpful. I will just remove this thing. Okay, and we will be including this. Okay, we can do one thing. instead of using the fixed header TCP and QIC. Okay.
Hello. Hello.
Hello. Okay, I'm audible. Uh, okay. Let me just check one more time because I'm sometimes not audible and I'm just doing my stream like that. I don't want to. Okay, I'm audible. Yeah, so what was I saying? Okay, so it was a flexible framework, or you could say flexible protocol that has been made, which can be uh, easily modified. Okay, so because everything is made in that way that people can experiment in on top of it, okay, and implement their own version of it, okay. So yeah, it is a big thing which is not happening in TCP, okay. So yeah, we have discussed till this thing, and then let's just this is why each individual component is also assigned the port for okay, so this is a concept which is required to guide you to understand because this will tell you why port are required. So this is nothing. Let's suppose if you wanted to run the backend, and let's suppose if you wanted to run the front end, and you wanted it to run uh, some other thing. Let's suppose if you wanted to attach as SSL certificate, you needed to uh, attach the domain name. So these are different things that you needed to uh, that you needed to attach in a single IP. Okay, so you needed different doors or different ports to uh, run those services. Okay, so in different ports, the different services is being run. So yeah, that is why we required ports to able to run different services in a single IP. We required port. That is simple. This is the concept of four tuple that I have made. I just made note of these all the things. These are all the same thing that I have explained you previously. Let's read about read about what is a domain name. Okay. So the domain name I already told you. It is something that is making a user friendly thing to able to easily remember by user. Okay, so it is harder to learn the IP address itself, and it is easier for human or the user to remember or to type a domain name together. That is why it is been made. Okay, so it serves this single purpose, but it has other purposes also. So domain name itself divided into three parts. Okay, so the first part is TLD, which is top layer domain, which is like .com, which is the left part, or the last dot right side is being called TLD server. Okay, so that is what it is. Okay, so this can also be like .in, so it is an Indian server. dot UK, so it is a UK server. .com is a commercial server. Okay, so that is how it is divided. Okay, and if you have like if you let's suppose if you have content uh, on the left side of the last dot. Okay, of the domain name. Okay, so that is something which is called 2LD. Okay, or second level domain, which is described which is, let's suppose in the case of google.com, is Google. Okay, and if you are divided the domain name into three parts, which is the case for some use cases. Let's suppose we will take the example of your college ID. Okay, which is something like Rahul. For my case, Rahul Saman at the rate tech. Then there is this uh, .edu .in. So edu is something which is of like education department, so it is defining the organization. Okay, if it is divided into three parts, uh, the second part is called, I mean, the between part is called the 2LD, and the first part is called 3LD, and the last part is obviously TLD, from left to right. Okay, so the second part is describing the organization itself. So if it is EDU, it is Education Department organization. Okay, so it could also be CO, which is commercial. Okay, and the last part is defining this TLD server, and the first is the name itself, the name of the name of the that domain name that you have purchased. You can purchase it from different websites like GoDaddy or maybe some other websites. You can explore it on your own. Okay, so yeah, that is what domain name is, and we required the domain name. I already told you why we required it, and there is a concept of DNS, how DNS is connecting uh, the domain name with IP address. I don't wanted to recall myself. Okay, so these are all the important concepts that we have learned so far, and there is not some there is not much in hosting, so that is why I don't make note of it. We will be discussing DNS in tomorrow's stream. Yeah, that is all I have to say for today. We will be learning Java also. So this is the okay. We can use some other website which is like W3 School. to learn the basic of Java. So it is also a good website for to learn from. Okay. So this is the basic structure of Java. There is this class main, and this main, I think it should be corresponding to the file name inside which this code is. Okay, or is it this one? Yeah, this class name. Okay, so the class name should be uh, no, is it the class name or this name? I don't know, I just forgot. Okay, I have a little understanding how is it working. Off stream I have tested it out. Okay, so I forgot I am also a beginner in Java. Okay, so we will be learning what Java is. Okay, we can use different website to understand. Yeah, that is all for today. I think we have a successful stream. We revise all the concept that we learned so far. We will be discussing like not like this. We will be, as we go forward, we will be just highlighting the topic, and we will be revising in detail only the important topics. Going forward, we have a lot of notes. So if we revise it like this that we have done today, so it will going to take much more time. Yeah, so let's see how is it, how we are going to do it going forward. So yeah, that is all for today's stream. If you have some doubts, you can ask me on live stream, or you can also comment in this stream if you watching my video offline. If you like the video, make sure you like the video, okay? And make sure you subscribe the channel if you like seeing content around backend or maybe in Java. Okay, we will be streaming around C++ also very soon. Okay, yeah, that is all. Thank you for today. Good night.